Today we're moving on through Unit 3, which we have just now gotten into our whole transformations and everything. And today we are going to be doing reflections. So we're going to be looking at specifically what it looks like on the graph, and also we're going to be looking at how it looks algebraically, meaning mathematically, whenever we plug it into the formula, okay? So let's go into that. All right, so the first thing we're going to jump into is exactly what the key points are, okay? So when we're looking at this, pre-image, remember, is going to be the image before. So that means if we're talking about the pre-image, that means before it transformed into something else. So the pre-image is the before. So pre-image is the original points, the figure, or the original shape. So it's what you started out at. The image is the after. So you have your pre-image, the before, and then after we do the transformation, your image is going to be what comes out at the end. So the image is the new set of points, your new figure, or your new shape. So remember, pre-image, before, image is what comes after the transformation, okay? Reflections. Do not preserve orientation, meaning like if I reflect over something and go something else, it's not going to keep the same orientation. So like translations, when I translate that and move it, it's never going to change orientation, meaning it's never going to turn, it's never going to look different, it's always going to be the same, okay? But it does preserve rigidity, meaning it doesn't get bigger, it doesn't get smaller, okay? So reflection only changes orientation if it flips over a line, okay? So now what we're going to look at, today we're only going to be looking at the x-axis and the y-axis if I reflect over that. So if I reflect over the x-axis, my pre-image, my original point x and y, is going to change into x negative y. So that means whatever your y-coordinate is here, I'm going to change it to its opposite. So that's what happens when you go across the x-axis. On the y-axis, going over the y, I'm only going to change the x-coordinate. So x is going to change to its opposite. I keep that y-coordinate, okay? So that's how you do that mathematically. So now to put this into play and give you guys a little bit more extra look here, I want you to look at this. Reflection has an FL in it. The word flip has an FL in it, so that's an easy way you can look into. Reflection means flip, okay? And so we're going to jump into that on example number 1, 2, and 3, and hopefully you guys can understand. Here we go, let's jump to example number 1. All right, guys, so looking at example number 1. So on example number 1, it says we need to reflect rectangle ABCD over the x-axis. So that means I'm taking this image and I'm flipping it over the x-axis here. So if you'll look up top on your rules, the rule is x comma y is going to be changing into x comma negative y. So that literally means I'm taking the coordinate here and changing it to negative on the y over here. So mathematically, it's super simple to do that. So literally, I could go ahead and look at that and see A is going to be positive 2, 1, 2, 3, 4. So 2, 4. So A is going to be, I'm going to write it right here in a different color actually. So let me get a different color so we can see it. Okay, so parentheses 2 comma 4 would be A, and it is changing into x comma negative y. So my x coordinate is 2, and then my y coordinate's changing to the opposite, which would be negative 4. So that is going to end up being your A prime, okay? So let's do the same thing to B. So B looks like it's going to be 8, 4. Okay, so now B is going to be 8, 4. Okay, so I'm putting it through the same situation. I'm taking my original and changing it into over the x-axis. So that means I'm keeping my x-coordinate the same, and I'm changing the y-coordinate to its opposite, so negative 4. So right now, if I look here, and I'll do it in a different color so you can see it, I'll do it in like a bright color here. Let's do this one right here. Look at this. Big dots here. Okay, so let's look at A, 2, negative 4. So over 2, down 4. So this right here would end up being A prime, okay? So now 8, negative 4. So over 8, down 4. 1, 2, 3, 4. So this is where B prime would be. So that's how you end up doing it mathematically, just putting it through the system there and then flipping it. Another way of doing it is, I know that I'm going over the x-axis. So that means you would start at that line and then count over and then go over the line that many. So for instance, I'm going to pick yellow here so we can see it. From the x-axis, D is 1 space away. So that means I'm going to go back to the x-axis and go one space away on the other side. So this right here would end up being D prime. C going to the x-axis is going to be one space away. So I'm going to go one space away on the other side of the x-axis. So that would be C prime. So ladies and gentlemen, if I was to actually connect these dots here, this would end up being the reflection of A, B, C, D over the x-axis. So I showed you guys how to do it mathematically by using the formula. I also showed you how to do it by counting, going from the x-axis and counting. So for instance, go into A, from the x-axis, 1, 2, 3, 4. Go back to the x-axis, 1, 2, 3, 4, and it landed exactly where I plotted it earlier. So this is reflecting over the x-axis. Let's jump over to example number 2. Okay, so now look at example number 2, and it says we need to reflect rectangle EFGH over the line, the y-axis. So I'm going to be reflecting it over the y-axis. So again, if y'all look up top on your rule over the y-axis is I'm taking my original coordinate x, y, my pre-image, and then my image is turning into negative x comma y, which means I'm changing only the x coordinate to its opposite, okay? So I'm gonna do the same thing. I'm gonna show you how to do it mathematically, and then I'm gonna show you how to do it visually, okay? So let's go ahead and start with letter E here. So E is all the way over here. So I'm gonna go over 2, and it looks like I'm going up 1, 2, 3, 4, 5, 6, 7, 8. So 2, 8 is gonna be the coordinate for E. And then if I end up doing it through the translation, I'm doing negative x, y. So that means it's gonna be negative 2 comma 8. I'm keeping the y, I'm changing the x, okay? So that new coordinate here, if I was to plot it, I'll use purple here, is gonna be negative 2, 8. So I'm gonna go over 2, and then I'm gonna go up 8. So up 8 right here. So this would end up being E prime, okay? Now I'm gonna do the same thing with F. So F is all the way over here. So I'm gonna go over 1, 2, 3, 4, 5, and then I'm going up 8 as well. So with that being said, 5, 8 is gonna be my coordinate, and then I'm putting it through the system negative x, y. So I'm changing the x coordinate to its opposite and keeping the y coordinate at 8. So that means that coordinate there, if I was to change the color here, bigger dot here, is gonna be over 5 and up 8. So I'm going over 5 and then up 8 should stick me right here. So ladies and gentlemen, if you can see it, this is actually gonna end up being F prime, okay? So that's how you would do it mathematically, by putting it through the equation. So now I'm going to show you how to do it physically by counting here. So I know I'm reflecting over the y-axis. So let's go ahead and do G now. So from the y-axis, which is right here, 1, 2, 3, 4, 5 spaces away from the y-axis. So I'm reflecting over. So now I'm going to count the other way and go 5 spaces. So 1, 2, 3, 4, 5. So ladies and gentlemen, my coordinate here for the reflecting over the y-axis is going to be right here for G prime. And I'm putting prime because that's the change. That's what's happening after, okay? So now let's look at the next one as well. So now we're looking at H here. Let me use a different color here. So from H here, from the y-axis again, starting at the y-axis, 1, 2 spaces away, reflecting over, 1, 2 spaces away. So ladies and gentlemen, right here is going to be the ordered pair. So I'll go back to my purple again. Right here is going to be my ordered pair for H here, or H prime. So ladies and gentlemen, if you want to look, this is going to be the rectangle EFGH reflected or flipping over the y-axis. You can see it's flipping. F is flipping all the way over here, okay? So again, that's how you do it mathematically, and then that's also how you do it physically by counting if you wanted to do that, okay? Let's jump over to example number 3. All right, so on example number 3, it says point C is located at -4, -5 in the coordinate grid. What is the location of C prime if it is reflected over the x-axis? So I learned earlier, x comma y is going to be changing into x comma negative y if I'm reflecting over the x-axis. That means I'm changing only the y coordinate. So that means I'm going to take my point, which is point C, which is -4 comma -5. This is my pre-image. And when I put it through the transformation, it's going to come out the other end as my y being the opposite. So x is going to stay the same, and I'm going to change my y coordinate to its opposite, which would be positive 5. So ladies and gentlemen, the coordinates for C prime is going to be negative 4, 5 whenever I go across the x-axis. Okay? All right, now in the bottom right-hand corner of your paper, again, guys, this is your challenge question. So again, this is kind of a gauge to see if you're ready to move on into your skill check. So if you can do this on your own, that probably means you're ready to move on. If not, you need to show me this that you don't understand. I can show you some more examples to kind of get you some help. Show me your notes. I can open your skill check, and then we can move on from there. Have fun. Let me know if you need any help.